Good afternoon everyone. I am Chanda Devnath, one of the PMRF fellows of ISR Berhampur. So I am the course TA of this course Retrosynthesis in Organic Chemistry. So here I usually discuss about some topics and some reaction mechanism, also some name reaction which may help you to solve your assignments. So in this class also I will discuss some topics which has been included in your assignments, and by solving this you will get an idea how to attempt those. And moreover, as I am discussing about some previous year NET and GATE questions, so it may also help you to attempt any competitive exams. So let's start. If you want, after seeing this video, if you are interested to check the previous ones, those all have been uploaded and links are provided in the NPTEL website, so you can go and check from there. So let's start. So in the previous classes I have discussed about different type of name reaction which have been again and again included in your assignments, and in the classes I have also discussed about pericyclic reactions, oxidation reduction reactions, and many more. You can go and check the slides also, those have been also uploaded. So today I will discuss about some stereochemical aspects. So stereochemical aspects for formation of a double bond, and also stereochemical aspect for reaction of a double bond. So how stereochemistry of a substrate will affect the formation of a double bond, and after the formation of a double bond, if you want to react that double bond, and if you are adding some chiral reagent, or if there is any chirality in that substrate, how it affects the reactivity of that double bond, I will discuss about that. So first, we all know about substitution reactions. So one of the type of substitution reaction is SN2 reaction. This is highly stereospecific. Why? Because this is a bimolecular reaction, and attack of the nucleophile is from the back side of the carbon. Attack of the nucleophile is from the back side of the carbon, because of that there is a inversion of configuration through this pentacoordinated transition state, and there is an inversion of configuration where the nucleophile enters exactly at the opposite position of the leaving group. So this is highly stereospecific. So if you are starting a reaction with a S, after reaction the product will be R. So there will be, if your substrate, if your starting material is S, then after the reaction your product will be R. So there will be totally inversion of configuration. This is the energy diagram where the substrate reacts to this transition state and give us our product. So let's try to get an idea. I have given you this question. It came in GATE 2012. So they have given this alcohol type of bromo alcohol type of compound and added base. NH is a base. We know that NH it dissociates like Na plus and H minus. This H minus acts as a strong base and abstract proton from this wedge. So how this reaction will go through? What will be the stereochemistry after the reaction? What will be the stereochemistry of the product? We know that in case of SN2 there will be a inversion of configuration. Now just think. So in this case, if we try to draw the substrate, this bromine is below the plane, whereas they haven't shown the stereochemistry of the OH because it's not a chiral center. This is not a chiral center, but this is a chiral center. So stereochemistry of this is not determined. So now this OH can attack from the above and also from the below. It's not OH actually. After proton abstraction, it will be O minus. Now this O minus can attack from above the plane and below the plane. How it will attack? Obviously, whenever the leaving group is whichever plane, the incoming nucleophile will come just from the opposite side. Now here bromine acts as a leaving group. So bromine is below the plane. So it will come from the above the plane. So it will be above the plane. So here the new bond formation will be above the plane because there will be a new bond will be above the plane. So the correct option will be option C. So the new bond will be above the plane. Okay. So I just gave an example how the stereochemistry works. Like if you want to do a inversion of configuration, then there the attack will be just opposite to the leaving group, and the new bond will be just opposite to this bond. So it is below the plane. So the new bond which is formed here, it will be above the plane. Okay. So this is another. So this is substitution. Similar to this substitution, if we check, now we know about elimination. Now if we compare, there are two types of substitution. One is SN1, SN2. There is also two types of elimination, E1 and E2. So E2 and SN2 are comparable. If you try to compare, see both are bimolecular. In both cases, both are concerted and stereospecific. What is the difference between substitution and elimination? In case of substitution, the leaving group is substituted by a nucleophile. Whereas in case of elimination, the nucleophile or the base take up the adjacent proton, and this proton will come here and eliminates the leaving group from the system. So in case of substitution, there will be an incoming nucleophile which will attack to the carbon center and substitute the leaving group. But in case of elimination, there will be no nucleophile, but there will be a base which will take up the adjacent proton to the nucleophile, to the leaving group, and this, after taking this proton through the movement of electron, this leaving group will leave from the system. So in case of E2 elimination, the deprotonating age, whatever the base will take up the proton, that proton and the leaving group should be anti to each other. Similar to that, just try to compare so that you can remember. Similar to the substitution, in case of substitution, the incoming nucleophile and the leaving group should be anti, that means should be at the opposite plane. So wherever the leaving group is, the incoming nucleophile will come from the opposite plane. Similarly, as in this case, the nucleophile is actually this bond electron. After taking this proton, this bond electron is moving and eliminating this bromine from the system. So here, actually the nucleophile is this bond electron. So this bond electron should be anti to this bromine. So this bond should be anti-periplanar to the leaving group. And we will get, so this will goes here and bromine will be eliminated and get our product. Understood? So in case of bromine, in case of substitution, that is specifically E2, specifically SN2, in case of SN2 substitution, the leaving group and incoming nucleophile should be anti, and it should be approaching from an opposite plane of the leaving group. In case of elimination, E2 elimination, the eliminating age should be anti-periplanar to the leaving group. This word is very important. In some interviews also, professors usually ask that what is the basic feature of E2 elimination. So that is anti-periplanar. what is the basic feature of the, if it is not anti-peripheral, E2 elimination won't be take place. You can explain if you want. If you go to the orbital picture also, I haven't discussed here, but if you go into the orbital picture also, from the orbital picture this can be also. So this orbit comes here, and there is a bond. So after elimination, so there is a formation of a new bond. So this goes here, and there is a orbital overlap. So you can explain this from orbital picture also. So the basic need or the requirement for the E2 elimination is anti-periplanar arrangement. So there is one example of elimination. Just try to solve this one. We will solve more question on this elimination topic for formation of double bond. Before this is a simple question. So here they have added a base NaOET. It will give Na plus and OET minus. It will give Na plus and OET minus. Now this NaOET will abstract the proton. So you can see this OTS is anti to this H. So it can OTS is the leaving group, and this H is anti to this OTS. So it will take place through E2 elimination. So after that the product will be, we just try to draw this as it for your simplicity. So CH3, both the CH3 would be in the same plane, and pH and C. So correct option will be option D. Okay. So let's go to our next topic. So we will discuss about stereochemical aspects for the formation of double bond. So we have discussed about E2. Now we will discuss about stereochemical aspect for the reaction of a double bond. So one of the famous reaction of double bond with the in a stereo-specific manner is the hydroboration. So in organic chemistry, hydroboration refers to the addition of a hydrogen and boron bond to the certain double bond or triple bond involving carbon. So this chemical reaction is useful in organic synthesis, and this reaction always follows the anti-Markovnikov rule. So what is anti-Markovnikov rule? According to Markovnikov rule, the H will be added where the number of H is already greater, but here it will fall anti-Markovnikov. So which is the less sterically hindered part? This. So this will be attacked by this boron, and H will attack here. So this is anti-Markovnikov rule. If it is Markovnikov, then H will added to the less hindered. But in case of anti-Markovnikov, H will be added to the more hindered side. But here it will follow the anti-Markovnikov rule. So this is the mechanism where this boron H been added across this double bond through this transition step, will get this hydroboronated product. Now if you substitute this CH3 with deuterium, then this H will attack to the more hindered side, and boron will attack to this less hindered side, and we will get this product. Now after this step, suppose we add H2A2. What will happen? Wherever the boron is present, in that place boron will be substituted with the OH. If you add acetic acid, then wherever the boron is, that place will be substituted by the H. I am not discussing the mechanism. If you want to get an idea about, you can go and search. Otherwise, you can ping. You can put a message on the video. I will try to provide you the mechanism. If you have doubt regarding the mechanism, how this is possible, you can there's a message. I will try to add that one. So if you add on a boronated compound, if you add H2O to NOH, what will happen? This carbon-boron bond will be substituted with a carbon-oxygen bond. And if you add acetic acid, this carbon-boron bond will be substituted by a carbon-hydrogen. So there, based on that, there is a question. So if you see across this double bond, which is the less hindered side and which is the more hindered side? Obviously, this carbon is less hindered, so in this part boron will be added. Whereas in this plus H. Then as I said, if we add H2A2, wherever the boron bond is, that will be substituted by a OH bond. Okay. Wherever the boron bond is there, that will be substituted by a OH bond. Let's go to our next topic. So that is oxymercuration reaction. So this is totally opposite of hydroboration reaction. In case of hydroboration reaction, that follows anti-Markovnikov fluid, but here it follows the Markovnikov fluid. So in organic chemistry, the oxymercuration reaction is an electrophilic addition reaction that transforms a alkene into a neutral alcohol. In case of hydroboration, then followed by oxidation, we also get a alcohol, but the product is in result of anti-Markovnikov. But here we also get a alcohol, but product will be following a Markovnikov rule. In oxymercuration, the alkene reacts with the mercuric acetate in aqueous solution to yield the addition of an acidoxymercury group and a hydroxy group across the double bond. The carbocation are not formed in this process and thus rearrangement are not observed. The reaction follows Markovnikov's rule. The oxymercuration part of the reaction involves anti-addition of the OH, but the demercuration part of the reaction involves free radical mechanism, and it is not stereospecific as H or OH may be seen or anti to each other. So here in the less hindered side, first mercury will be added and the more hindered side OH will be added. After that, if you perform reduction, this mercury will be substituted by the H, and as a result we will get an alcohol following Markovnikov rule. So this is the mechanism where the H is added to the less hindered side because of its large bulky side, whereas the OAC, this incoming nucleophile will attack to this more hindered and give us OH. After that, if you perform a reduction, that H minus H minus, we will substitute this Hg from the system and we will get, but this is not that much stereo specific as hydroboration, but here you can get always give a alcohol following Markovnikov rule. So now we will try to solve some question based on this boron chemistry, this hydroboration reaction, and also some reaction to form double bond following a stereochemical aspects. So here one question is given: in this reaction major product form is X, so you have to determine the S. So we know that I have already told that if after following the hydroboration reaction, if you add acetic acid, you will get the C boron bond will be substituted by a CH bond. Okay, so just try. So let's start. So we know now between these two carbon sides, which one is less hindered and which one is more hindered. Obviously this carbon is less hindered and this one is more hindered. So after reaction, now it has a D in this boron, so there is a BD bond, not a BH. So deuterium will be added across this double bond. So we will get deuterium added across this triple bond. This deuterium is already there, so I am just marking as a circle one was already there in the system. There is a boron part. Now if we add acetic acid, what will happen? The carbon boron bond will be substituted by the carbon hydrogen bond. So the product will be, there will be a D, there will be a D, but as this is acetic acid, simple acetic acid, so this will be H. As this is a simple acetic acid, so we will get H here. So the correct option will be option D. Okay. Let's go to our next question. In the following reaction, what will be the major product? X is the major product. Now just keep in mind about the stereochemical aspect. Now we have discussed, or not, I don't remember actually, in case we have discussed about reduction. Now for reducing ester and ketone, we usually use lithium aluminum hydride, but in case of acid, BH3 act as a good reducing agent. So here one ester and one acid group is given. So this B2H6 is selective to acid, selectively reduce selectively reduce acid. Okay. So if we just reduce it, now after this OH will attack to this CO2 and OIT will remove and we will get. So this so the correct option will be option D. Okay, the correct option will be so this here will be the C. So the correct option will be option A, not D. The correct option will be option A. Okay, understood everyone? So let's go to our next question. Identify the reagent A and B in the following reaction. So there I have told already that if there is a acid, that will be reduced by boron BH3, and if there is a ester, that will be reduced by a lithium aluminum hydride. Now they have given a substrate and added two different reagents to get two products. So here you can see the carbonyl group is at this part. So that means this part was unreacted, this part was unaffected, only this part was reduced because there is no such carbonyl group. So here the acid group has been reduced. So B will be BH3. So B will be BH3, and here the carbonyl group is intact. So that this part was reduced. So A will be LILH. The correct option will be option A. It was easy. Whenever there is an acid, so from there you can get an idea that if it is an acid, which reagent you will use? BH3. And if it's a ester, which reagent you will use? We will use carry LH. Okay. Let's go to our next question. Identify the product form in the following reaction. It is also boron hydroboration followed by oxidation. So just give it a shot. We'll solve it together. So between these two sides, which one is more hindered? Between these two sides, which one is more hindered? Obviously this part. This is more hindered. So the boron will be added to this position, whereas the H will be added to this position. Now this is a trans. So the which plane is more available? The upper plane. So the boron will be attacked from the upper plane. So this H will add here. Whenever there is no methyl group above the plane, so always the concave plane is more vacant for addition. So boron will add here and H will add this position. Now if you add H2 to NaOH, what will happen? Boron is added to this position. Okay, and here the methyl. Now if you add H2O2, what will happen? This part will be substituted by a OH. So OH will be above the plane and methyl will be below the plane. So correct option will be option A. This methyl will be below the plane and this OH will be above the plane. So correct option will be option A. Understood? Let's go to our next question. The major product of the following reaction. So what will be the major product of the following reaction? So it is very simple. I think you guys can do that. Which one is the more hindered side? Obviously this one. So boron will be added here. After that it will be substituted by OH. So the correct option will be option C. Sorry, boron will be added here. This is the more hindered side. I made up. This is more hindered side. So H will be added here and boron will be added here. So the correct option will be, then the boron will be replaced by a OH. Now there is a yes. You have to. This is simple. That you from there you can get an idea. Okay, the product will be this one. There will be OH. There will be methyl. But from the product you can see there are two types of products are given. One is cis, another is trans. Now you have to get an idea of, according to the stereochemical aspects, which one will form. From it is simple, like the OH will be here and CS, but from how, if you want to know from the stereochemical aspect, you have to know how this is possible. Now, if you just, you don't have to go to the, suppose this cyclohexane is given. Okay. Now we know that hydroboration always takes place in a concerted manner, so the hydrogen and boron will come from the same plane. It will added in a cis manner and it will come from a same plane. So suppose both are coming from below the plane. Both are coming from the below the plane. So then methyl will be above the plane, H will be below the plane, again boron will be below the plane. Because boron and H are coming from the same plane, boron will be also below the plane. Now this boron will be substituted by a OH through oxidation. So then OH will be below the plane, then OH will be below the plane and this methyl will be above the plane. So which one is the correct option? Option B. So this is the stereochemical aspect. You form the reagents, you just get an idea that okay, this product will form. But if you don't know how the stereochemistry control the arrangement of the product, there will be a mistake. So if you want to plan a retrosynthesis of a compound, you have for most of the natural products are chiral. So we have some centers are cis to each other, some centers are anti to each other. Now to plan a retrosynthesis, you have to get a specific stereochemistry of the product. In that case, here by choosing correct reagent and substrate, you can get this anti arrangement in the product. So next question, the major product form in the following reaction sequence. What will be the major product form in the following reaction sequence? So first there will be hydroboration followed by oxidation. So it will give, I have discussed about the mechanism multiple times, so I am just drawing the product directly. So this is the more hindered side, so H will be added here and OH will be added here. And if H will be added here, then this methyl and OH should be anti to each other. So, and now there is another aspect. Here you can see this part is above the plane. This part is above the plane. So the incoming boron hydrogen will try to come from the below the plane, because this above plane is already hindered by this ring structure. So this incoming boron will try to come from the below the plane. Okay. So just by seeing the stereochemistry of the substrate, you have to determine which attack will be preferable. Now because of this ring structure, this boron prefers to come from the below the plane. Now through oxidation, this carbon boron bond will be substituted with a carbon oxygen bond and there will be a OH. they have added PPH3 date and 4-nitrobenzoic acid. Date PPH3 means which type of reaction? Is always a Mitsunobu reaction. We have discussed about Mitsunobu reaction in our previous classes. You can go and check. So date PPH3 means you can just blindly you can go that this is a Mitsunobu reaction, and if there is a Mitsunobu reaction, what will happen? There will be an inversion of configuration of this OH. There will be an inversion of configuration of the alcohol. There will be inversion of configuration of the alcohol center. So there will be inversion of configuration of the alcohol center. So there will be actually this is acid. Now in the next step, if you add K2CO3 ethanol, this part will be hydrolyzed and we will get our OH. Now if you add K2CO3 and methanol, this part will be hydrolyzed and you will get this part will be hydrolyzed because OH will OMe, methanol OMe minus will attack here and this open up and we will get this as our product, option A. Okay. So by this choosing correct reagent in a correct order, we can get a specific stereochemistry of the product. Now if you just stop from the BH3H2O2 step, what will you will just get a anti-alcohol, anti-arrangement of the methyl and alcohol. But if you perform 2 more steps, what you will get? You will get a cis arrangement of the methyl and OH. Okay. Next question. Now we have talked about oxymercuration, demercuration. So what will be the major product form in the reaction? So I have told about that oxymercuration, demercuration always follows the Markovnikov rule, just opposite to the hydroboration. In case of hydroboration, that follows the anti-Markovnikov rule, that hydrogen attacks to the less hindered side. But here it will follow the Markovnikov rule, means hydrogen will be added to the I said the opposite one. In case of hydroboration, that follows the anti-Markovnikov rule, that hydrogen is added to the more hindered side. But here it will follow the Markovnikov rule. Markovnikov rule means, I have talked in the previous slides, that Markovnikov rule means hydrogen will be added to the less hindered side. Okay. So here, which one is the less hindered side? This one. So hydrogen will be added here and OH will be added here. So correct option will be. Now if you add NaBH, now as there is a OH minus in the system, that will also react with this ester system and hydrolysis will perform, because you can't control, right? That you can't tell your reagents, okay, you have to react only this part, you can't react with this part. So as there is ester and as OH minus is also there in the system, this ester will be also hydrolyzed and we will get this as our product. Okay. So you have to, so if you just go through the reaction and if tick this one, that will be wrong. You have to see that if there is any other reactive center is also available which can react with your reagent. So that will also possible. So here the ester will be hydrolyzed along with the demercuration, demercuration. For the following two reaction A and B, the correct statement is, so there are two reaction A and B. From A what will be the product and from B what will be the product. You have to determine that. So we have talked about elimination reaction, E2 elimination reaction, and for E2 elimination reaction you need anti-peripheral rearrangement. So if you draw the cyclohexane, I am drawing the A. This is the anchoring group. So this bromine is above the plane. Acid is also above the plane. Now if we add base to this, there is a H available here. So there is an anti-peripheral arrangement. So this H will goes here and bromine will be eliminated. Simple way. Because there is a anti-H available. There is a anti-H available. So because of that, it will eliminate it and we will get this as our product. Now, as base is given, so it will be, acid will be deprotonated and form this salt. After that it will undergo the decarboxylation. It will undergo the decarboxylation and we will get this as our product. Okay, we will get this as our product. Now, so we are getting this as from A. From A, that is clear. Now you have to determine what we will get from B. So what is the difference in case of B? This acid group is below the plane. This acid group is below the plane. Below the plane. Now in presence of, now there is no anti-H available to eliminate this bromine, but in presence of base, this can be deprotonated to form a carboxylate salt. As there is no H available, this goes here and there goes a decarboxylation. So the correct option will be option B. Okay, correct option will be option B. What will be the major product formed in the reaction? So we know for elimination we need an anti-arrangement of the leaving group and the adjacent H. So this OH is here. So there is no H available anti to this OTS. Right. There is no H available anti to this OTS, but there is a OH. So what will happen? This reaction will go through like this. Resulting this as our okay. Understood? So as there is no H available and in presence of base, H minus will deprotonate this OH, and through a this carbon-carbon bond act as a break in the system instead of carbon-hydrogen bond and eliminate OTS from the system. So instead of, in case of elimination, instead of normally CH bond get broken and eliminate the leaving group, but whereas in this case the carbon-carbon bond will be broken and it will eliminate the leaving group from the system. This is the similar one. See, the same question came into NET examination simultaneously, the same question. So if you try to solve this type, if you get an idea how to solve this one, they see there is no change. Totally they have given the same question. In June gave 2009 and the same question repeated in NET 2013. Okay. So what will be the major product formed in the following reaction sequence? So we have learned about oxymercuration, demercuration. So what happens if this is a less hindered side, this is more hindered side. So less hindered side will be occupied with H and more hindered side will be occupied with OH. Instead of H2O here as a nucleophile they have given a amine. So instead of OH, NH2 will be added. Instead of OH, NH pH will be added, because in case you have know about if you see the mechanism of oxymercuration, demercuration, here see the alcohol, the water molecule is attacking, but here instead of water they have given amine. So instead of water this amine will attack and form this as our product. Form this as our product. Now they have given heat. Let's go to the next question. So what will be the major product formed in the following reaction? Now you have to find there is a leaving group, that is OTS. So if there is any H available trans to it, then it will undergo elimination. But see, there is no trans H. So what will happen, and there is no heat also, because before elimination there is a probability of substitution. So, and as there is a phenyl group, it will undergo a neighboring group participation. It will undergo a neighboring group participation. So this will attack here and OTS will remove from the system. Forming this 3-member cyclic ring. Now this acetic acid will attack here to this center and it will open up. So we will get this as our product, where acetic acid will take the exact place of the living group. Where the acetic acid will take the exact place of the living group. This is can we get from the neighboring group participation. So if you want to get your incoming nucleophile at the same position of the living group, you can think about neighboring group participation. So this much for today's class. I hope I have tried to discuss the variety type of questions and it will help you to solve your assignments and get an idea. So this is the overview. I hope it may help you. So thank you everyone for attending my class. We will meet in the next class at the same time on next Sunday. I will upload this video and you will go and check there. Okay? Any question? I hope it's clear. Thank you everyone.